All right. So thank you, everyone. So I think today, Gavin is out, so I will cover him. So before the talk, I would like to introduce a little bit about myself and Inspurs. So my name is Han Wang. I'm the principal engineer and the senior architect in our system engineer group of Inspur System US. So as we know, Inspur is the number 3 server solution provider in the worldwide, and we are growing extremely fast. And we also are leading HPC solution provider in the world. So, so we have business over 120 countries. And in China, we are the number 1 server solution provider in general server in terms of the total server shipping volume. And we are also the number 1 in all the AI specific solution provider. So we have overall market share of around 60% for China market. So for the leading tier 1 customer, we almost like more than 60%. For some typical specific customer, we are over 90%. So we have a very broad scope of customer across all kinds of fields. So we deliver all kinds of AI specific solution to them, and we optimize the solution for each very specific AI use cases, workload, and service. Yep. Okay, so before we talk about the architecture and the detailed implementation, we probably need to address some couple questions. So first, what leads to the rapid growth of AI industry? And the second one is what is the gap for the future new use cases, new application, new service, and how to close the gap. So the first question, what leads to the rapid growth of AI industry? So we need to look at from technical perspective. So the first we think is the data availability. So as we know, for nowadays, so we have a lot of data generated by mobile internet, social network, and all kind of smart device. And so this is a tremendous data generated every day. So you will forecast when the 5G deployment this year for large-scale deployment and more edge computing, IoT, so everything got connected. So we are expecting more and more data coming. So it will come in from your social activity, your personal data, also the device sensor in your home, the smart, from every aspect of your smart life. So we have tons of data coming, and we have tremendous data availability for all the AI application training purpose. So number 2, the computing. So the progression of all the heterogeneous computing, like a new CPU combined with new GPU, FPGA, ASIC rest. So this dramatically improves the parallel computing performance, which enable us to do more complicated AI training inference. And number 3 is the algorithm. It's not just about algorithm, it could be also the framework. So as we know, we have so many open framework and the project going on, and allow us to adopt the latest innovative algorithm to be applied easily to all kinds of fields for all kinds of new application cases. So this is from technology point of view. The second is from the people lifestyle point of view. So we actually are so get used to all the benefits brought by all the new AI application, app service. So all this are changing our lives. So we are get used to that. This brings a lot of business potential, which ultimately stimulate the rapid growth of the AI industry. So as we talk about So there's a gap because we know when the 5G, the Internet of Things come in, so we have smart life, smart city, smart community. So everything gets smarter. So we have more and more, lots of new application cases, new application scenario coming out. So how's the gap between the current AI infrastructure can support to have all these new features, new workload scenario to be supported? So this is a gap. So right now, the central point for AI solution is like for very specific AI application or service, we are designing very specific AI solutions to accommodate that particular use cases. But in an environment, so this world is changing so dramatically quick. So we have new application case, new workloads popping up. So we need to have very flexible, heterogeneous solution to accommodate all the rapid change. So this is a gap. And so how to close this gap? So in my point of view, in my provisioning, so we have to think about and come up with an architecture with very flexible, heterogeneous resources pooling instead of just focus on the application itself. So it will allow us to have agile and very flexible and very high efficiency to for that particular scenario. Sorry. Okay, so this architecture, so this is the implementation of that type of infrastructure. So it will be a heterogeneous resources pooling. So one implementation is allows to like a very flexible scale out. So we need to think about, we need a system, an architecture structure to allow us very flexibly assign the resources. And also, we need to be able to easily scale up, scale out, very easy to composable, and orchestrate all the resources. So that means we need a building block. So this is one high-level building block. So don't restrict to the GPU itself. So in this building block, we are leveraging a two-level PCI switch matrix. So the basic structure is a bipart type graph or interconnection structure. So on the bottom 4 PCI switch, we can allow total 16 PCI slot. It could be the standard or the special PCI slot, which allowed us to connect into 16 GPU or other acceleration card. It could be the FPGA card. It could be some fast storage NVMe storage, or it could be the high bandwidth, the I/O card. So on the top level, the 2 PCI switch allow us to scale out and also can connect to multiple hosts. Okay, so we talk about heterogeneous pooling. So when we talk about, so if this architecture can allow us to scale out very easily, and also we can have the building block allow us to build a very large pooling, flexible pooling of all kinds of resources. It not just restricted to GPU, it could be everything. So even inside the single building block, you can have very flexible combination of different cards, different resources. And if inside a single box, you can also change the components on the fly, and you have flexibility to assign different process, different card to different application. So also you you have the capability to connecting multiple nodes. So the advantage of this heterogeneous pooling is all the PCIe fabric is leveraging all the PCIe fabric, so we can achieve low latency. And also the expansion became very easy. And also we can deploy with very high density. So this is one of the detailed physical implementation for OCP specific. We have an equivalent version of ODCC. The customer is Baidu. We have shipped a very large volume. We have already deployed that product. So this is the equivalent version in the OCP form factor. As you see, it's a 4OU box. It's a resource pooling box. So it really depends on the application case you want. So it could, if you want lots of high performance training, then you can populate up to 16 GPU for that high performance training purpose. So if you want lots of resources for the inference, so you can populate up to 16 FPGA. So if you want a balance between training and inference, you can adjust the number of GPU and FPGA. So if you also want some direct data fetch, allow GPU to fetch the data from NVMe drive in the building block in the same box to reduce the latency. You can also replace some cards with NVMe drives. So this box, this building block has a very flexible, very high flexibility. So in terms of design for a single specific AI application, so this architecture allows us to have really high flexibility. You will assign the optimized resources pooling for that particular AI use cases. And if the single box cannot afford the capability, you can also do all the scaling out using the clustering through PCIe fabric. So we have a solution demo in our Inspur booth. So it's building via a PCIe fabric. You can do the composable, and on top of that, there's an orchestration layer. So it will dynamically assign the resources for all kinds of AI application. Also, it can build up the dynamic bare metal server for AI application cases. So this is also one application case for the single building block. So in this case, it's for the image visual recognition. So also the classification. So in this box, we have 16 GPU. So the upper bound we connect to 4 compute nodes. So also the top left side say, if you want to change the number of the compute node, if you want more resources to do dynamic resources allocation, you can spread out by the PCI fabric to have multiple building blocks into this picture. So on the right-hand side, so we do some benchmark for this particular case. So on the top is using Café. We run the AlexNet using batch 128, and the linearity of the speed up is around 14 point something. So on the bottom side, it's using different framework, MaxNet, on the GoogleNet with a batch size 128. So this time the linearity of speed up is different. So it's lower, still 12.17. Yeah, so this is just a showcase. So for this particular AI application case, we have this 16 GPU resources pooling. So if you have another application case, you can dynamically change on the fly. This is a physical change. Also, if you do through the PCIe fabric, you can do the composable and orchestration. So that's kind of some virtualization. You can dynamically assign the resources pooling for each specific AI application, so you don't need to change physically all the components. So this provides a very high flexibility to meet all the coming changes when the 5G and IoT and all the new AI application scenario coming out. So that's pretty much what I have. So if you have detailed questions, please feel free to visit us at the Inspur booth. We can demo you this box, also the composable infrastructure. All right, thank you.